All right, my friends. So let's do 3E and F here, all right? So these are both problems that are about air resistance, okay? So usually we ignore air resistance, but again, in the real world, there is air resistance, so it's good to at least talk about it, all right? So for 3E, we'll do that one using this green here. We've got a 45 kilogram box, so draw the box. It's falling, so don't draw a floor, right? It's not sitting on a floor. We got 45 kilograms worth of mass, so start with your force of gravity. It is not negative 9.8. The acceleration of gravity is negative 9.8, but your force of gravity is, go, brain, mass times negative 9.8, okay? So if you do that, you get negative 441 newtons, all right? Now, because it's falling, that means that our velocity is downwards, and our air resistance will resist that downward velocity. So our air resistance is going to be up. There you go. Okay. So all we got to do for here now is, I think those are the only two forces, right? It's falling. So there's nothing touching it. There's no friction. There's no Sally or Roy or anything. It's just falling, right? Okay. So we can find our net force. That's just going to be the total force. It's going to be gravity plus air. So negative 441 plus 135 gives you, what is that, negative 306? Is that right? I just did that in my head. I should probably double check it. If I'd been smart, I would have done that before I started recording, but I'm not. So, yes, good. And so now I can find my acceleration. Net force over mass, negative 306 newtons, pulling a 45 kilogram thing down, divided by 45. Gives you negative 6.8 meters per second squared. Cool. So notice it is accelerating downwards, not as quickly as it would be if there was an air resistance, right? It's only negative 6.8 instead of negative 9.8, right? And notice that it's going to speed up, all right? So a thing that we talked about in class was the idea that as an object goes faster and faster and faster, the force of air resistance gets bigger and bigger and bigger, okay? So if you imagine this thing speeding up, your air resistance is going to get bigger. It'll keep speeding up. Air resistance will get bigger. It'll keep speeding up. Air resistance will get bigger. Eventually, you get to a point where your gravity is still pulling this thing down with 441 newtons, but now it's moving down so fast that your air resistance exactly cancels out the force of gravity. All right, and at that point, what is true is your acceleration is 0 and your net force is 0, all right? The velocity at which this occurs, is called terminal velocity. All right, so this is 3F. Okay, there you go. When you're at terminal velocity, your net force will always be 0. Okay, cool. Come see me if you don't understand that, or if you have other questions that I didn't answer here, come see me before, after school, student support, whatever you got. Stop recording. Yes, I do want to. Thank you for asking.